I'm trying to get back onto the streaming every Sunday kick, which was my original goal. So in my talk, efficiently coding. Yeah, so let's just do Q&A, I guess, for the rest of this. For efficiently coding for modern CPUs, by GHC needed prim-up fixes in order to have better calling conventions. Was that fixed? Yes. In theory, that is all fixed. They're still missing a ton of prim-ops for me to be able to compile down to it, but it's one of the targets that I'm looking at for Coda, which is to compile down to this very weird SIMD-ish sort of Haskell. As a sort of middle ground for performance reasons. So yes, we finally got all that calling convention stuff addressed either in 8.4 or it might, some of the last little bits of it might be in 8.6. I think there's still some problems. Like I don't believe right now, for instance, that I can use like using foreign import prim, using the foreign prim support that's added to GHC. I don't actually believe that I'm allowed to make my own prims that use the LLVM registers in their calling convention stuff. I think that's currently just an accidental oversight. I'll have to reach out to Ben Gamari and see. I know when I looked at the code, it didn't look like it was supported. But I didn't actually test it. All right. What I'm going to do, I think, is I'm going to put up a straw poll for what do you want to talk about next time. So what I would like is suggestions from the audience here. If anybody just wants to dump things into Twitch chat, I will add them to the straw poll, and then people can vote on them here once I give the link. I'm not going to talk about Australian accents next time. Things from me. Fixing quantified constraints. What other projects, questions, concerns, etc. can people think of? Co-free, co-monad, co-algebras. Okay, parsing is matrix operations. The whatchamacallit, CYK / Valiant parsing. What else we got? Do I have the old straw poll? No, not really. You'd have to watch the old stream to see what it was. Parsing and matrix operations, fixing quantified constraints, co-free, co-monad, co-algebras. We need some more options here. Don't really want to do an extended Q&A again. There were other weak algebraic structures that I have that I've been wanting to play with. Oh, the first stream we did a bunch of stuff on abelian. Abelian commutative applicatives and commutative monoids and commutative semigroups. And at some point in time, we should probably get around to shipping that, just so it can be on Hackage. So whatever the last mile is of that. There was some discussion between the first and second one about the building a Markov chain Monte Carlo. using that abelian package and the notion of a commutative applicative. So, like, take the free commutative monad given a commutative applicative and build a nice monad for dealing with Markov chain Monte Carlo and doing Gibbs sampling when it's cheap. Just packaging up auth for release. I'll make sure that we can allow multiple poll answers because some of these things are pretty short. More algebraic. Structures. All right. Here was the old straw poll. Let me pull that up. So the old straw poll. Yeah, this is the idempotence. General introductory session. I don't want to do another Q&A. We did this one. And we kind of did this one as part of it. Like, it was kind of a mixed bag. More work on unpacked containers. I'm really bored with that, so I don't want to do it, so I'm going to say no. Backporting commutative to older GHCs and testing. General lens deep dive. I'm going to say no on that one myself. Because I'm not really in a hurry to do a dive. I'll include CRDTs. But CRDTs, idempotence, propagators. I'm gonna glue those together into a single. Do I ever do anything interesting with GADTs? I use lots of GADTs. I'm not quite sure what would constitute interesting. I think we've got a pretty good list. I'll just create this as a poll, and then as for whether or not we'll leave it up in the Discord, yeah, but I may not check it after today because I'll probably forget. So let's just create a poll. Allow multiple poll answers. I'll just skip to results rather than voting myself. And hopefully we can watch this thing fill in. This was like magic the first time I saw this happen on a Twitch stream. Well, when the first time it happened on mine, I guess. So it was the first time I saw it happen. Oh man, we have very, very split opinions. Why don't I use Linux over Mac OS X? To be honest, I use this Mac because it's the smallest laptop I can carry around. That I feel is well made. It's not a particularly great love of OS X. As a matter of fact, I'm having a great deal of anxiety with working in OS X these days because I do a lot of graphic stuff as my fun time. And the let's randomly deprecate OpenGL and OpenCL, etc., has made it so that I'm not really in a hurry to I'm not very happy with Apple at the moment. Let's just say. But the thing is, for the most part, it's a desktop environment that just works. So It's sort of the standard, why do you, if you go to Silicon Valley and you look around, you'll see everybody and everybody's got a MacBook. It's mostly that. The machine that I'm actually streaming off of here is a Windows machine, because I can run all the fancy video hardware and stuff like that I need in order to stream efficiently. So I'm streaming through a video capture card into a Windows machine. Do I think it's worth spending a lot of cash on a MacBook? Probably not. Like if you're just trying to get code done, maybe not. For me, it's really the convenience of it. So what is taking the lead? Co-free Comonad coalgebras. I'm going to have to come up with a use case for co-free Comonad coalgebras if I go that direction. I don't particularly have one. What is in the second place here? More algebraic structures on rings, CRDTs, idempotence propagators, and semilattices. All right. I mean, I think I have a decent amount of stuff to talk about for CRDTs, idempotence propagators. Nobody wants to deal with packaging, though. I'm noticing that there's one vote between two packages. Coding the game of life using Comonads. I've already done a blog post series on doing cellular automata with Comonads. So there's this series on... where is it? Oh man, I'm logged in. Oh no, I'm not. So you can't see all my private stuff. Conquering folds. There it is, cellular automata. So I did this triple of articles. The first one was, let's use the store Comonad to build automata, and then I built like all of the, rule 110, etc. variants, and showcased how to package it up with Usod. Unfortunately, School of Haskell stopped running user code at some point, so this used to be a really adorable, like it will produce the SVG at the bottom when you click run, and since that stopped running there, it lost a little bit of its oomph. And then for the second part, I built PNGs using another Comonad. So I built a Comonad for left folds and then used it to compute checksums that were needed in order to produce PNGs in live. So it wound up being like 75 lines worth of code that can actually includes code for generating compressed PNGs from scratch. And then built another thing that used the dual of the writer monad in order to, or I believe I called it the traced Comonad, in order to make sure that you can't have rules that depend on where you are in the space, but then embed that into a store Comonad. And so, I do have a series right now about doing automata in Haskell. So I don't know that it would be terribly informative to do it here on the stream. Oh, there are some things that I would like to do as maybe little streams. Like, I don't know that they're worth a whole Sunday. But if I can find some day during the week or something like that, I might want to sit down and go through... like my Lazy Promises package and stuff like that. Just so I can have a video online of me having gone through it from start to finish for people who are curious about it. Like I've got lots of little packages on Hackage. Where's uploaded by? All right. So I have a ton of little packages, and I really haven't given talks on a significant cross-section of them. So I would be willing to go through and dive into some of these. Applying category theory to programming is great. What limitations do I see in terms of practicality? I don't see as many limitations in terms of practicality as you might think. As a matter of fact, what I find is that category theory is a pretty awesome toolbox of like ways I can rearrange my code. And it's a good way to say, oh, actually, there are no other way. Like, it gives me lots of little results of I can stop where I can find that I can stop looking for things that I can now prove don't exist. So in terms of practicality, I find a lot of practicality in the sense that it has shut off a number of like little denial of service attacks on my own brain that I've been performing for many, many years, where I was like looking around for something, and then now I can know it's not between the initial and the terminal object in this space, and so I can show it just doesn't exist. And so those kind of things, like I get so much value out of getting that time back that any other like limitations in the domain I think is somewhat limited. How long does it take to brainwash one's brain to think in category theory? That's a good question. It took me about 6 months, but I already had a math master's. I think you can do it a lot faster than that. I did it through like kind of the steepest hill decline possible, which is I went in through McLean's book. I think starting from Linsner's book or from Audi, you can get in much more gently. And I think Bartaj has a bunch of material that really helps a lot there as well. I think there's a lot more material to learn category theory than there was when I tried to get in. And yeah, so Wes Hancock linked the Bartaj's category theory for programmers articles. There's also a PDF for those of you who want to print out a 600-page book or something. I mean, Bartaj's approach is a little bit quirky and Haskell-y, but again, if you're trying to apply this to Haskell, there's some benefit to that. I mean, in some sense, one thing you'll find is this: if you're using category theory the way a Haskeller uses it, it's almost like how to put it? It's almost like someone who reads a category theory book and then misses the point. In a lot of cases in category theory, like we talk about like functors from all of this gigantic category to all of this other gigantic category. And in Haskell, we're often playing with like little pieces of something that a category theorist would do in full generality. And so we're often limited to working point-wise with little toy-like examples. Some of that's through limitations of the language. Some of that's through limitations of the libraries that we currently have expressed in the language. But in some sense, it makes like Haskell a little laboratory for like learning how to do category theory badly. So you might have to be careful if you start trying to pick up category theory that you don't pick it up with too strong of a Haskell accent. What would be good for the next level of category theory material after Bartaj? Trying to think. Where he stops is actually pretty far along. I think what I would do there is start digging into, like, you can skim through NCAT I would expect that you're going to bounce off of most of it. But when you do so, you'll find a bunch of stuff about various forms of like infinity groupoids and whatnot. And so I think that is where like the next direction to go would be. Like look at like homotopy type theory. And I think that would give you another direction to keep carrying on. I think the homotopy type theory stuff is really interesting. And there's a lot to be said. There's a lot to say there that is outside of the vocabulary of Haskell pretty far. Can the code density transform be considered a killer app for a category theory? I think it worked out really, really well that it worked out. And like finding it as a way for improving the performance of free monads and stuff like that and to right associate your monads, I think has been a really nice like feather in the cap of like how well category theory works for programming in general. Do I have experience with model theory? I have some. And so you can express model theory category theoretically. So there's all sorts of nice tooling there. So I don't know if I think they do complement each other. All right, I think this might be a decent place to break. I realize I'm about an hour earlier than I usually end. I'm completely out of steam and my throat is gone. So if I keep talking, I'm going to not be doing so well over the next couple of days. So I would like to thank everybody for showing up for the stream. And have a good day.
You're still here? It's over. Go home. Go.